Welcome friends once again to this online platform. It's a Sharp Tuition Center, a place where dreams take a flight. If you are enjoying this video for the first time, at the end of our discussion, there's a link that's going to be provided. So tap on that link, then it's going to take you to our YouTube channel, Sharp Tuition Center. Then subscribe to our YouTube channel, give it a thumb. Under the comment section, leave a comment there. Then don't forget also to share this video or this link to your friends so that them too can enjoy, especially if you have friends or you are doing the GCE for this academic year 2026. You are a grade 12 candidate, you are preparing yourself for 2026 final examinations. You are a grade 10, you are a grade 12, but still you want to catch up in some areas where you feel like at least feel free to contact us on 0974 19 27 92 0974 19 27 92. It's a Sharp Tuition Center, a place where dreams take a flight. We come back now to our discussion. So the subject for today is physics, and we'll look at the topic called scientific measurements. Very interesting topic, especially that in our daily activities we do measurements. Okay, we rely so much on measurements, so I encourage you to pay more than usual attention to our discussion under this topic called measurements. So under measurements, colleagues will look at the base and the derived quantities that we use or that we have. Maybe some may be wondering, what is this so-called measurements? So measurement refers to the process of finding the size of a physical quantity. It is as simple as that, friends. It is just a process of finding the size of a physical quantity. Is measurement important? Of course it is. Measurements are essential for understanding. They are essential for interacting with. They are essential for quantifying the world. They are essential for ensuring accuracy in our daily tasks. They are essential also for scientific research. Not only that, measurements are also essential for the trade. They are essential for engineering. Look at the application of these measurements. Let me take you to a real practical example. You get sick. You visit the hospitals. What happens there when you find the doctors? They are going to give you medicine. Now, this medicine that you are going to get from these doctors, they are going to put the dosage. Okay? They are going to put the dosage. Now, how are they going to put the dosage? So, they are going to put the accurate dose for your medicine. They'll give you the accurate dose for your medicine. Why are they giving you the accurate dose for medicine? It's because of measurements. Okay? Let's say the diagnostic testing. It is also because of measurements. Let's talk about the engineering and the construction. For you to ensure that your components fit, the structural integrity and component fit, what do you use? You use measurements. Science, the same science that we learn, enabling repeatable, the valid and reliable research, is because of measurements. We can talk about the commerce in our trade. For you to have the standardized weights and volumes of your products, you look at the measurements. So, colleagues, there is no doubt that measurements are very important and they play a crucial role in our lives, in our daily lives. We can talk about some of you even know the size of your shoe that you wear. Look at the size of a shoe that you wear. You find that in Enma Vara size 8, in Enma Vara size 6. why are you saying you must wear size 6? Why can't you just wear any size? Well, it's because of the measurement. They will look at the size of your feet, then they will make a shoe according to, so that you fit. Imagine you wear size 8, then they buy you a shoe, let's say size 12. It is impossible, right? So for you to have accurate size, you need measurements. Let's talk about time. Kakalila che 12 hours ngenge mwataba at it's lunch time. Who told you that it's lunch time? It's because of the measurements. 06 hours, it's time to go to school, because of the measurements. The clothes that we wear, in a kasuit kanga ni mavala ka size 46, or in a size 30. All these, they come up as a result of the measurements. So we look nice when we wear clothes because of physics. There is accurate size. Okay, we look nice when we wear shoes because of the accurate size, and this accurate is coming as a result of the scientific measurements. So these scientific measurements are derived or are categorized into two. So we have the base and the derived quantities. So the base and the derived quantities are physical quantities that consist of the numerical magnitude as well as a unit. So these physical quantities are grouped or are categorized into two types. We have number one, what we call the basic. So number one, we have what we call the basic. So we have the basic quantity. So number one, we have the basic quantity. Then number two, we have the derived. So number two, we have the derived. So we have the derived quantity. Okay, so these quantities that we have, the base quantity and the derived quantity, are all physical quantities, but these are different quantities. Why do I say so? Let's look at the first one. Let's differentiate these two quantities. Let's look at the basic quantity. The basic quantities, these are quantities that cannot be obtained from other physical quantities. These basic quantities cannot obtain from other physical quantities. They are obtained or derived directly from a measuring instrument. Let me give you an example. You cannot obtain time from the length. Okay, you cannot obtain time from the length. So time has an instrument that you use. Okay, you use an instrument to obtain time. Okay, so the examples of these base quantities, we have a number of them here. We have a number of them here. We have the length, we have time, we have mass, we have temperature. It is impossible for you to obtain or to derive temperature from the mass or the time. It is impossible. So these basic quantities are only obtained directly from a measuring instrument. The derived quantities, now these derived quantities, they can be obtained either by multiplication or division of other physical quantities. So when talk about the derived quantities, they are derived or obtained from other physical quantities through multiplication, through the division. You obtain these quantities. Let me give you a practical example. When we start looking at energy, work and power, or let's talk about energy, work and power. You know that work is given by this formula. Work is equal to the product of force and the perpendicular distance. So work is equal to force times the distance. So what does it mean? You have the force which you are multiplying it by the distance, and what are the units for work? The units is what we have, the joules. You've seen that? So we are using the multiplication to derive the units of work from the force and the what? And the distance. Okay, we have a lot of examples that we can talk about the derived quantities. We can talk about the volume. We can talk about the speed. We can also talk about the density. We can also talk about the pressure. Okay, so some of these we use multiplication or the division for you to come up with a unit. For example, the speed. You know that speed is given by distance over time. For you to come up with the units for speed, which is meters per second. So you have derived these quantities from other physical quantities. Okay, there is no need for you to use the instruments for you to come up with the units, as unlike the basic quantities where you only need the instrument for you to come up with the units. Okay, the most units commonly used in combination of the base units, they are known the derived units. And we have talked about the examples of velocity, which is meters per second. We've talked about the acceleration, meters per second. We've talked about force. We've talked about the energy. Okay. We have what we call the SI units. The system or Systeme International units. This is the international now that we use worldwide. Okay, so scientists over the world have now what we call the international system of units, the Systeme International units, what we call the SI units for physical quantities. So for base quantity or basic quantities, we have the length. What are the SI units? Meters. International. We have the time. What are the SI units? The second. And the symbol M. The symbol S. We have the mass. Kilogram. Kg. We have the temperature. Kelvin. We have the current. Ampere. In amps. A. The symbol A. So these are the units that we use. When I take you back before 1960, we didn't have the System International or Systeme International units before 1960. So now scientists had to sit down and come up with these standard units to ensure that there is accurate size of the measurement for these physical quantities. Okay, in an exam, they can give you a question to give the exam a difference between the base and the derived unit, and it will carry 1 or 2 marks. So don't leave that question blank. Okay, they can give you a question to write the examples of the base or examples of basic quantities, the examples of derived quantities, and etc. So it is important that this is the foundation of what we'll be doing, especially in physics, because we will rely so much on the units, you rely so much on the magnitude, and where are we getting these from? We are just getting these from the 3 states of matter, which is solid, liquid, and gas. So measurements are important as they allow us to do the comparisons. Okay, as they allow us to do the comparisons. We can proceed to the next topic, next subtopic. Okay, so this is now vectors